Dear students, Assalamu alaikum. We have seen the overall behavior of a BJT transistor in the form of the characteristic curves. Today, we will see how we can use a transistor for a practical application. There are various applications in which a transistor is used. On-off switching and amplification is the common application, and the most common one is the amplification. So we have selected the amplification as an application to be studied in this lecture. This is a basic circuit of an amplifier in which you can see the input AC signal Vi is being injected through this capacitor to this amplifier, and the amplified output, that is the Vout, is being taken out through this capacitor. The user of an amplifier is only interested in the amplification factor. Means if he want to amplify its input signal into 100 times, so its amplification factor would be 100. For example, for a 5 millivolt signal, if this amplifier is giving a gain of 100, then the output will be 0.5 volts. So the design engineer like you have to set a gain of 100 if you want to sell or design this amplifier for the user which is requiring a gain of 100. So as a design engineer, you must know that which of these resistances or electronic components are playing its role to set the amplification factor, and what this DC source is doing here. Why is it necessary? And if so, then what is the relation of this source with these resistances and transistor? So to design an amplifier, we need to do the DC analysis. Why this DC source or DC biasing is necessary to design an amplifier, and you will be able to see what is a Q point, what is the load line, and what are the relation of this DC analysis, DC biasing, Q point, and load line with the amplification factor of an amplifier. Let's start the DC analysis of this circuit. So we can see that this DC source is applied to this circuit through RB1 and RC. And this DC source can see only this part of the circuit because these capacitors will be open circuited for this source. So it cannot see beyond these capacitors. So we can find the DC equivalent circuit of this circuit by opening these capacitors, and we will get this circuit as shown in figure B. To analyze this circuit, it is easy to Theavenize this circuit at this node. The output seen out of the base of this NPN BJT transistor. We have already studied this, and you can revise your previous lecture to get a Theavenized circuit like this. So this whole circuit will be obtained.